Hey guys, today I will be talking about the unit circle and how we can connect it to some previous concepts that you may have learned in previous math classes. So the unit circle, what it basically is, it helps us represent 45, 45, 90 triangles and 30, 60, 90 triangles as easy sine, cosine, tangent values. And these are values that you need to memorize, and I'll make another video about this. But first, let's review a 45, 45, 9 triangle and our 30, 60, 90 triangles. So we know that a 45, 45, 90 triangle has values of x, and x rad 2. And we know that a 30, 60, 90 triangle has x times rad 3, and 2x. And always remember, for 30, 60, 90, the short side is always x. So, what we can do is we connect this to the unit circle, but first let's also review sine, cosine, tangent, and our reciprocal identities of cosecant, secant, and cotangent. So, you know that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And just in case you don't know those values, you can obviously use the phrase SOHCAHTOA to help you memorize those values. And we also have a reciprocal identity. So we have cosecant is equal to hypotenuse over opposite. Secant is equal to hypotenuse over adjacent. And then cotangent is equal to adjacent over opposite. And then remember, all these have data. So these identities you do need to know if you want to memorize values of the unit circle. But just in case you have trouble memorizing them, like which one goes which, like this cosecant goes to this cosine or sine, you can just remember the opposite letter goes. So S goes with a C and C goes with a S, and then tangent, cotangent, those are pretty easy to memorize. So now that we've reviewed that stuff, what we can do is we connect both of these triangles to the unit circle. So I'm going to do that right now. So now that we have these triangles on our unit circle, what we can do is derive the values of sine, cosine, tangent. And before I cover that, the way that we get these values for sine, cosine, tangent is we write them as a coordinate. So like x, y. But how do we know which one goes on the x and which one goes on the y? Well, there is a very easy way to know which one goes where. So we know that sine is opposite over hypotenuse. Opposite over hypotenuse. This is the opposite side. This is our y-axis. So we know that sine is equal to y. Similarly, we can do same with cosine. Cosine equals adjacent over hypotenuse, and adjacent is our x-axis. So cosine is equal to x. And if you're wondering what tangent is just the slope of that line. We actually get an identity. Tangent equals sine theta over cosine theta. And the reason why we get that is because this is basically a slope, y over x, change in y over change in x. So that is how we get our value. So we always write our values as cosine theta and then sine theta. And remember that cosine is y and cosine is x and sine is y. So using this value, we can derive the values, the SOHCAHTOA values of a 30-degree triangle and 45 and 60-degree triangle. But we'll first start with 30-degree triangle. So for sine, right, what does sine equal? So we know that in a 30-degree triangle, sine is opposite over hypotenuse. Opposite over hypotenuse. We just cancel the x's out and we get 1/2. Now we do the same with cosine. Cosine is adjacent over hypotenuse. Yeah, adjacent over hypotenuse. Just cancel those out and we get 3 over 2, rad 3 over 2. And we have tangent theta. So remember, tangent is opposite over adjacent. So we have x over x rad 3. The x's cancel out. We got 1 rad over 3. But remember, we can't have a rational on the bottom. So we times this by rad 3. And we get a value of rad 3 over 3. So sine of 30 degrees, and these should all be 30, not theta. So remember, sine of 30 equals 1/2. Cosine of 30 equals rad 3 over 2. And tangent of 30 equals rad 3 over 3. So the good thing is that for any 30-degree triangle, it will always be these values. And if I were to ask, oh, what's the point value on here, you would write rad 3 over 2, 1/2, because that, remember, x and y values, x is cosine, y is sine. So before we do the 45-degree triangle, next I'll do the 60-degree triangle, because if you know the 30-degree triangle, all you can do is just inverse the values, and I'll show you what I mean. So we know that for a 60-degree triangle, sine is equal to rad 3 over 2, cosine of 60 is equal to 1/2, and tangent of 60 is equal to rad 3. So notice with a 30 and 60-degree triangle, 60-degree triangle, the sine and cosine values are switched, because remember, we had sine of 30 equals 1/2 and cosine of 30 equals rad 3 over 2, and these values are essentially just flipped. These values are just flipped. So that's an easy way to memorize the values of a 60-degree triangle. So before we go into the 40, I would like to cover the inverse function. So for now, let's just work with sine. So let's say I have sine of 60, and I asked you what is cosecant of 60 degrees. So all you would need to do is you just flip these. So when you flip this, you have 2 over rad 3. But again, we can't have rational on the bottom, so we times this by rad 3 to cancel out that. So we get 2 rad 3 over 3. And same for the reciprocal identities, or reciprocal trig identities. They are always the same value. So there are 6 values that you will need to memorize, but just in case you can't memorize these reciprocal trig identities, what you can do is that if you have the regular ones memorized, you can just flip them and get those values. So now we will cover a 45-degree triangle and their values, and in my opinion, that is the easiest to cover, because both the sine and cosine are the same. So we know that sine of a 45-degree triangle or angle is rad 2 over 2. Cosine of 45 degrees is rad 2 over 2, and tangent of 45 is equal to 1. Notice how these two values are the same, and that is because these two sides are the same. This side is x and this side is x. Opposite of hypotenuse, adjacent over hypotenuse. You just get the same exact value. And yeah, this is, in my opinion, the easiest triangle to memorize, because these two values are the same. So now that we have that covered, I want you to notice, look at how we have written. Look at how we have this written. What we can do is that there are 2 ways of writing this. We have degrees, which is the way I just wrote it now, and we also have radians, which is in terms of pi. So I'm going to label this circle in terms of radians, and then we'll go over how we can identify certain degrees and radians. So I've labeled the unit circle in terms of pi, and the way, basically, radians are how we can describe units or degrees in terms of pi. So a full circle has a circumference of 2 pi. That's actually where we get the formula of 2 pi r for the circumference of a circle. And half a rotation is just pi. Now half of that is pi over 2. And 3/4 is just rad 3 over 2. So the way we can write our degrees as radians is you have 30 degrees is pi over 6, 45 is pi over 4, and 60 is pi over 3. And the way you can memorize these values is just remember, kind of like with cosine, cosine, tangent, and our reciprocal identities. The 4 goes with the 4, and then 3 go with the 6. So the opposites go with the opposite, and then 4 goes with 4. So the usefulness of these is we can just write sine, for example, sine of pi over 6, and then you would have to know the value of that, which is just 1/2. So for that, we can just know the value, and this is just another way of writing 30 degrees. These two ways are just essentially the same. They're inversible. So what, for example, if I gave you the angle of 30 degrees, and you have to write that in degrees, or sorry, radians. So the way you would need to write that in radians is, remember, this 1/2 is pi, and 2 and a full rotation is 2 pi. So the way we can just write this, because remember, this is just pi, we can write this as 6 pi over 6, because these can just cancel out. So this is pi over 6, right here will be 2 pi over 6, we just rad 3 over 2, and we can go along. And then right here, right, we just get 6 pi over 6, and remember, we go around until we reach that, because this is just equivalent to 12 pi over 6, right? And this is just before this 2 pi. So this is 11 pi over 6. Now you could memorize these values because obviously these values are all the same, but it's easier to just go around a unit circle and look at which radian value there is. And the last thing I would love to cover is sine, cosine values on these on the x and y axes. I've written down the values of sine, cosine, tangent for each of these coordinate values. Now, before we identify these values, we have to remember that cosine and sine is how we write our coordinates. So, if I were to give you this point, and I told you to identify the values, we know that sine is our y value, and here at y, we're not above or below y, so this would just be equal to 0. And the same would be with 180 because it's also at the same y level. But for cosine, it's a little bit different. Cosine, remember, is x. So if our point is here, our cosine would be 1. And similarly, for 180, it would be -1 because cosine of 180 would be all the way over here. Now, tangent, remember, tangent is just the slope of our line. Fun fact, this is actually where we get this trig identity, sine squared equals cosine squared equals 1, because that is just the Pythagorean theorem, and that is our slope. This is our slope. So tangent is always the slope of our line. This is tangent, right? So if we have a line going this way, what would be the slope of that line? That line would be 0, because the slope of the line is 0. Remember, rise over run. And similarly, this would also be 0 because rise over run. Remember, tangent is the slope of our line. Now, if we go to 90 in our 270 degree angles, be over here and over here. Now, using the same logic as last time, sine would be 1, and sine of 270 would be -1. And cosine would be 0 and 0 here. Because remember, these values are, because sine is y, our y's are over here, our y is up here, and sine is 1 and -1. Same thing for our cosine values. But for tangent, remember, tangent is just our slope. what is the slope of a vertical line? That's undefined for both these values, because you can't have a straight line up and you can't have the slope of a straight line. So our tangent values for 90 and 270 hour are undefined. That is it for the unit circle. If you have any questions, leave them in the comments below, and thank you for watching.